So what's the purpose of signals? In the end, signals give us and Angular a new way of handling data changes and of updating the UI. Without signals, so without this new feature, Angular relies on its classic change detection algorithm for finding out whether some data changed and the UI should be updated. You will also sometimes hear of that referred to as zone-based change detection, because under the hood, this classic change detection algorithm uses a library called Zone.js. In a typical Angular application, like this one here, data is changed by simply defining class properties and by changing those properties, for example, in methods that are triggered once buttons are pressed. That data, like this counter or this list of actions here, can then be output in the template by using template bindings like these double curly braces, so by using string interpolation, for example. That's Angular as you know it. And here I'm using a standalone component, but the code of course would be exactly the same if I were using ng modules here. This is how you manage and change data. Now, the advantage of this classic change detection approach, which is actually the default change detection approach in Angular, and which until Angular 16, where signals were added, was the only change detection approach, is that changes are detected automatically, and the UI is then updated automatically. Because of this Zone.js library, which is used behind the scenes by Angular, Angular basically finds out when these methods are executed. To be precise, it finds out when a click occurs, and it knows that you're listening to click events here, and it knows which methods are executed upon clicks. And it therefore then simply watches those methods you could see, and it sees which data you're changing, and it therefore knows that the data has changed once one of these buttons has been pressed, and it then goes ahead and updates the UI so that the latest state of your data is reflected on the UI. And that's why as we press those buttons, the UI is being updated. Angular, with its classic change detection algorithm, is taking care about that. Now, I don't know about you, but I would say that this current classic change detection approach sounds pretty perfect, right? Everything happens automatically. Well, that is of course good, but the downside is that the overall application performance could be better and the bundle size could be smaller. It is increased because of this Zone.js library that's being used for change detection. And since Angular has to watch for all those changes and has to check all your data and update the UI whenever anything happens that could potentially lead to a change in data, the overall app performance is not optimal. And that's the disadvantage of the current change detection approach. Application performance could be better, and the bundle size, the overall application bundle size, is actually increased because you have to include that extra library that takes care about this change detection. And that's where signals come in. Signals give us an alternative way of managing and detecting those changes, and they allow Angular to get rid of that extra library. They allow Angular to stop watching your entire application, and they therefore can lead to better performance and a smaller bundle. Because with signals, there is no automatic change detection. Instead, you, as the developer, basically tell Angular when data changes, and you also tell Angular where the data is being used. Therefore, Angular then also knows which parts of the UI need to be updated when that data changes, and that only those parts of the UI have to be updated. And therefore, you as a developer have slightly more work to do, but as a big upside, as a big advantage, you have full control and you can very likely achieve a better performance and get a smaller application bundle. And that's why signals were added and why you could consider using them. Though I will already say that the bundle size improvement and also the performance improvement will only really be available once signals are stable and only if you then fully switch to signals in your app. As long as you have at least one component that relies on the old change detection approach, Angular of course can't get rid of that code, and therefore you then won't get too many benefits. And at the moment with version 16 you also can't fully switch to signals yet, but in the future you will be able to get those extra benefits. But how do those signals work now? Well, let's stick to this application for exploring signals. And you find this starting project attached. The important thing about this project is that it uses at least Angular version 16. Older Angular versions don't have that signal feature, so you need 16 or higher. And with that, I'll copy that default folder and name it signals, so that in there I'll rebuild that default component, but now with my signals, and therefore these files can be renamed to signals component like this. Though of course the file names don't really matter. I'm just doing this here for this video. You don't have to rename the files to use this new feature, just to be clear about that. And in this signals component file, I'll also rename this component to signals component, though of course this is also optional. The naming does not matter at all. With that though, I got this all set up, and now in app component TS, I'll add my signals component here to the imports array, since I'm using standalone components here. And in app component, I'll use app signals instead of app default. And with that, we're ready to get started with signals. Now let's start by migrating this counter to signals. And that's, by the way, also a great advantage of this new signals feature. You can start using it step by step. You don't have to migrate your entire app and all your data in one step to signals. Instead, you can add small pieces here and there and migrate parts of your application, like this counter state here, this counter data. To turn this into a signal and to use this new signal feature, we first of all have to import from Angular core, and from there we have to import the signal function. With that imported, we now create such a signal here as a value for this counter property by calling the signal function like this. This creates a new signal object. And these signal objects in the end are simply wrappers around data, objects that can tell Angular once you changed the data, and that can be used by Angular to find out where in your application and your UI you might be using those values, so that Angular knows which parts need updating. So here, to set an initial value for this counter, we now just pass the initial value to signal. In this case here, the number is 0, though any kind of data could be a signal. You could also pass a string as a signal value, or a boolean, or an object, or of course also an array. Any kind of data can be a signal. In this case here, it's a number. So with that, we created a signal, and that's the first important step. Now, to update the signal value, we still reach out to the property, to the counter property, but we now don't update it by assigning a new value like this, or by incrementing it like this. Instead, this counter property now contains a signal. A writable signal to be precise, which means a signal that can be changed. To update it, you now have to call a method on that signal object. And Angular indeed gives you 3 methods for updating signal values. It gives you a set method to set a new value. It gives you an update method to set a new value based on an old value. And I'll get back to all these methods in just a second. And it gives you a mutate method to also update the value based on an old value. But again, I'll get back to these methods and the differences between mutate and update in just a second. Here we could, for example, update the counter by calling update, and by then passing a function to update. Because this update method needs such a function, you have to pass a function to it. And this function will automatically receive the old value, so in this case the old counter, because Angular will call this function here, and it will pass the old value to this function for you. And then in this function you should return the new signal value, in this case old counter plus 1, for example. That's how you could update this counter signal value. And of course we can do the same thing down here in the decrement method. Here we just want to subtract 1 instead of add 1. And that's how we can update a signal value after creating it. Now please note that actions is not a signal yet. This will change later, but at the moment it's not. So with that, we're updating this signal value, and we added this signal value. But if you now save everything and you have your development server up and running, you will notice that you got some strange output here in the UI. And as you press those buttons, the action log changes, but the counter, of course, is not being shown and also does not change. So something's wrong. So what is wrong with this application right now? Well, we are creating a signal and we're updating a signal, which is great, but we're not using it correctly in the template at the moment, in this signals component HTML file. Here, we're now using signals, and we're trying to output the counter like this, which is the correct approach when using the classic change detection mechanism, but which is not the right approach when using signals. Instead, when using signals, you have to execute those signal-based values as a function. So counter has to be executed as a function here. Now it is such a signal object, but it turns out that this signal object returned by calling signal here in the end yields a function. A function that can be executed in the places where you need that signal value. So for example, here in the UI, if you want to output the value that's currently stored in the signal, you have to execute this function. Now, when this signal function is executed here, Angular also basically recognizes and memorizes where this signal was being used. And it's then able to update the UI in exactly that place when the signal value changes in the future, which gives Angular an efficient way of updating the app and UI as your data changes. So with this change made here, this strange output is gone. We instead see the counter value, and as I click increment and decrement, the counter now also changes as expected. And that's how you can read and output a signal, by executing it as a function. And in a nutshell, that's it about signals. You create them by calling signal, you can update them by calling update, and you can output them by executing them as a function.